Hello, welcome to Saving Grace Homeschool. My name is Leanne, and today we are going to be continuing with exponents, where we already did the first part, which was just a revision from last year, and today we are going to be doing the integer exponents. We've already seen that 5 to the power of 4 means 5 times 5 times 5 times 5. So that 4 indicates how many times 5 is repeated. But now you can also have where you have a negative exponent. So instead of 4, you have negative 4. Mathematicians have decided to use negative exponents to indicate repetition of the multiplicative inverse. So instead of having a 5, we now have 1/5 multiplied by 1/5, and you do that 4 times. And then over here, you have, let me just zoom in. It's the same over here, where when you multiply bases, or the same bases, you add the exponents. That doesn't change when it's negative. You still go and add them. But now, when you have your answer as 2 negative 7, you write it like this. Say you flip the 2 around and then to the power of 7. The same is now for this one. You add the exponents, you get 2 to the power of 1, which is just 2. We are going to be doing these sums over here. So for the first one, it says express each of the following in the exponential notation in two ways, with positive exponents and with negative exponents. So the first one is with, if we go and we flip this around, okay, with positive exponents, you just say there's 1, 2, 3, 4, 5, 6 of them. So it is 1/5 to the power of 6. That's a positive exponent. If you make it a negative, you go and flip this 5 around to make it a so the 1 and 5 swap positions, and then the 6 becomes a negative 6. Over here, you have 4/3, so you make it a third to the power of 4. Writing it as a negative exponent, you flip the 3 and the 1 to make it a 3 and a negative 4. Alright, for the next one. In each case, check whether the statement is true or false. If it is false, write a correct statement. If it is true, give reasons why you say so. So how we're going to do this, we're first going to work out the one side and say if, or see if it gives you the right hand side. So for the first one, this, if we make it a positive exponent, it means this. Now if you're going to work it out, 1 to the power of 3 is 1. 10 to the power of 3 is 1,000. If you write that out as a decimal, it is 0,001. So that is then true. And your reasonings is your calculations to work it out can also function as your reasonings. Then the next one. With this, you have that means 1 to the power of 3/5 multiplied 9 to the power of 2 is 81. Then we have 1 and 3/5. That 3/5 is 243. Then we multiply that by, this is 81 over 1. So you get 81 over 243. And when you simplify that, you get a third. So this one is false. It's not 3, it is a third. Alright, looking now at this one. 25 to the power of 2 is 625. Then when you multiply this one, that is multiplying by that. So I've just made it positive now. You can write it like that because the 1 to the power of 6 also just means 1. And then you multiply. 2 to the power of 6 is 64. That is then, so the 624 and the, 625 and the 64 go at the top here as numerators. So that is then 625 multiplied by 64, and 10 to the power of 6 is 1,000,000. Which then, if you go and work that out, it gives you 1 over 25. So that is also then false. Then with D, this is true because all that you do is you just flip the 5 like we did over here, and then the exponent becomes positive. We are now moving on to question 3a. So for this one, it says that you can't use a calculator, so you must try and find a different way how to work it out, because the previous question was fine. You just had to show your reasoning and then you could use a calculator to get the final answer. For example, when it was calculated, say like 2 or 25 to the power of 3 or something like that, you could have used your calculator, but now you need to do it without it. So I'm going to be doing question 3a here because it's quite long. So we start off with 10 to the power of negative 3 multiplied by 20 to the power of 4. Okay, this 10 to the power of negative 3 can be written like this, multiplied by 20 to the power of 4. And if you make it over 1, then these two can be multiplied together, where 20 to the power of 4 is your numerator and 10 to the power of 3 is your denominator. So when you aren't allowed to use your calculator, you must try and find ways that your work can cancel out. So when it cancels out, you're dealing with a lot smaller numbers, because 20 to the power of 4 will be a big number and it might be hard to work out, especially when you're under a time constraint during a test. So for this one, you can see which two numbers multiplied together give you 20. So you get 1 and 20, but that's pointless because you're sitting with the same number. You got 4 and 5, but that's also pointless because it won't cancel out with a 10. But then you have 2 and 10. So you can use that for multiplication. But when you take out a 2 and a 10, this to the power of 4 applies to both numbers. Then you got 10 to the power of 3. Now you have that 10 to the power of 3 and that, 10 to the power of 4, and this 10 to the power of 3 can cancel out because 10 to the power of 3 can go in there 3 times. Then you're only left with 1 10. So it'll be 10 to the power of 1, which is just 10. 2 to the power of 4 is 16. Multiply by 10, and that answer is then 160. Alright, now for the next one, I can write it over here. You can do the inverse, so this is 5 to the power of 4. You already know that 5 to the power of 3 is 125, or at least you should know that. If you don't know that, make sure that you know all the numbers to the power of 3, say till about 7 or so, at least till 7 to the power of 3. And then you just have to multiply that 125 by one extra 5, so just an extra step to get 625. Alright, moving on to 4a, you are now allowed to use a scientific calculator to determine the decimal values of the given powers. So I'll just be giving the answers because you are allowed to use your calculator for this. Just make sure you get the same answer as me, otherwise you might be typing something wrong in your calculator. This one will give you an error. Okay, then B, it says explain the meaning of 10 to the power of negative 3. Well, that is the same as saying 1 to the power of 10, 3. And that 1 to the power of 3 is 1,000. And then we can convert this into a decimal. So you see there are many ways how you can actually convert 10 to the power of negative 3. Alright, then for question 5, it says determine the value of each of the following in 2 ways. The first way, it says by using the definition of powers. So what you do is if it's 5 to the power of 2, you are going to find that answer as being a 25. 5 to the power of 0, anything to the power of 0 is 1. Then you multiply them together. That is the first way how we're going to be working this out. I will then get on to your second way. So this is all of these are going to be for A, the method A. Okay, so this one, you first have to, you see, work out each value. So that is 3 to the power of 3, which is then 27. And then you work it out to negative 2. Then you go and rearrange that as 1 over 27 to the power of 2, which is then 1 over 729. Then for this one, 4 to the power of 2 is 16. Multiplied, this is now the opposite, so it's 1 over 4 to the power of 2. But we know 4 to the power of 2 is also 16, so we're going to have 16 multiplied by a 16th. These are the inverses of each other, so they cancel out to give you a value of 1. Looking at C now, you rewrite this as the inverse, and then you work it out. So 5 to the power of 2 is 25. And then this 5 is just 5. Then you say 1 times 1 is 1, and 25 times 5 is 125. Okay, I'm going to erase everything now because there's not going to be enough space to do the method B. So this is method B. For method B, you're going to be using the properties of exponents. So you're going to be adding the exponents because similar bases are being multiplied by each other. So for the first one, so this is now all the rules of exponents that you are going to be using. You first leave it as a 3, and then that's a 3 multiplied by negative 2. So it's 3 multiplied by negative 2, which gives you 3. 3 multiplied by negative 2 is negative 6. Okay, there's a negative there, you can't really see it. Which you then invert it. And that answer is 1 over 729. So you see you get the same answer as the previous one. The previous one is also 1 over 729. Then when you do this one, you add the exponents. So it's 4, 2 plus negative 2, which is then, that becomes a negative. So it's actually 2 minus 2, which is 0. And anything to the power of 0 is 1. So this is just showing you two different ways how to work out the same question. You can choose whichever one you are more comfortable with, or you can even alternate between the two methods because you see they get to the same answer. So sometimes the one method is quicker for one question, and then sometimes it's longer for the next question. So it's really up to you how you decide to use these methods. I'm just showing you both of them so that you, well, know the two different methods. Now for this one, once again, you add the exponents. So we have negative 2 plus negative 1. That is 5, negative 2. That becomes a negative. So it's a minus 1, which is then 5, negative 3. When you invert that, you get 1 over 5 to the power of 3. And 5 to the power of 3 is 125. Alright, then for question C, it says calculate the value of each of the following. Express your answers as common fractions. Okay, so for the first one, it's 2 to the power of negative 3. You want to first invert that to get 1 over 2 to the power of 3, because now it is in its fraction form. And 2 to the power of 3 is 8, so you can just say 1 over 8. Okay, over here, you need to have it as a common fraction. So it is, well, this is going to be, the answer is going to be 1 because it is 3 to multiplied by, this is also going to be 1 over 3 to the power of 2. So they're going to cancel out to give you 1 eventually, but it needs to be to the power of, it needs to be expressed as a common fraction. So you can make it as 1 over 1, 3 to the power of 2 over 3 to the power of 2. So it's up to you because your final answer when simplified gives you a whole number of 1. Then this one, you can first work out the inside to give you 5 to the power of negative 2. We'll go this way, which if you write it as the inverse is written like that, and then 5 to the power of 2 is 125. There is your common fraction. All right, here is some more over here, so we're just continuing. This is 1 and 3 squared multiplied by 1 over 2 to the power of 3. So the exponents are negative, so all I did was just convert it, or invert it, sorry. 3 to the power of 2 is 27, multiplied 2 to the power of 3 is 8. Then you can say 1 times 1 is 1, and 27 multiplied by 8 is 216. Okay, looking at the next one now. This is also negative, so you're going to go and invert it. And sorry, this one, I see this one's wrong. Wait. It's 3 to the power of 2, which is actually 9. And this one is still 8, so that's 9, which is then 72. So over here, this was the one that I actually worked out here. So it's 1 over 8, but it's plus now. So you see the difference between multiplied. With multiplied, you can go and just multiply the exponents, but now it's added. So the added, you can't do that. And it's 1 over 27. So now to leave it as a common fraction, you need to find numbers that both of them go into. So you can just multiply them by each other. They'll probably be easiest. Or I'm really running out of space. So this you can just multiply top and bottom by 27 to get 27. 8 times 27 is 216. Plus this, you just multiply by 8. So all that I did was multiply it by each other to get a common denominator. Then 27 plus 8 is 35. Over 216. Then you have to see, can it be simplified any further? And no, it can't. So then that is your final answer. This one over here, all that you do, you invert it. And 10 to the power of 3 is 1,000. That is then your final answer. Okay, then I have to just erase because this is not enough space. All right, now for this one, you have 2 to the power of 3, which is 8. And then you have, this is the opposite, so this is 1 over 2 to the power of 3. So you have an 8 plus an 8th. which is then just all that you do is you just add them together because you have a whole number and you have a fraction, and you just then add them together. All right, then for the next one, yeah, you multiply. So it is -1 multiplied by your -1. -1 multiplied by -1 is just 1, which is 3. Over here, you have 2, -3 multiplied by your 2, which is 2 and -6. Then if you go in inverted, so you see whenever there is a negative, all that you do is you just swap the numbers over. And 2 to the power of 6 is 64. Okay, last question. Which of the following are true? Correct any false statements. This one is false because that negative doesn't go in front of the whole number. All that negative does, it makes it into a fraction like that. It's got nothing to do with whether the final sum is negative or positive. It just shows you the positioning of that 6 in a fraction form, whether it is a numerator or a denominator. This one is also false because it's like that. That negative doesn't apply to the 3. So the 3 is actually still a whole number, which you can write as a numerator. It's only the x that is a -2, which can then be made into your denominator. This one is now correct. So you see the difference between this one and this one. This one, the 3 is also a -1. So you can make it positive by swapping between the numerator and the denominator. The x is negative, so you can make it the denominator. So that's the difference between these two. You must be very careful. Only when all of the numbers have a negative can you switch it to the bottom. This one is correct because this -2 applies to both of them. So it'll be like this. And then you invert both of them to get this final answer. This one, to make it -2. So to make it a positive, yes, it is correct. You just swap them around. And then the last one is also correct because you just keep on doing your inversions. All right, so that is also, yeah, so just be careful. You swap the 3 and the 2 and it becomes positive. You swap the 1 and the 3 and it becomes positive there. That is all for this lesson. Next lesson, we will be continuing on with scientific notation. Goodbye, everyone.